Hi, in this lesson, we'll look at the this keyword and how it can be used in our programs. Let's go. In the previous lesson, we learned a bit more about scope. Scope determines where in a program a variable exists. As we can see from this example, each variable exists in different contexts within the program, depending on where the variable is located. Generally, a variable exists only between the brackets it's initialized in. If there are multiple variables that share the same name within the same scope, then the variable with the more specific scope takes precedence. In this example, the instance variable number and the local variable number share the same name. When number is printed out in the print number program, the result is 10, not 0, because the local variable number is more specific in scope than the instance variable. This becomes crucially important when attempting to initialize the instance variables that we create for our class files. In this example, the name of the instance variables matches the formal parameters that are input into the rectangle constructor. When we create a new rectangle, 3, 9, and try to print the values of width and height, we see that the result is unusual, 0, 0. This is best illustrated by adding a printline statement in the constructor. As we can see, the value of width when printed in the constructor is the correct value that is input into the constructor, 3. The reason that the instance variables do not take the value of 3 is because the assignment width equals width in the constructor is using the formal parameter width instead of the instance variable width. Because formal parameter width has more specific scope, that's the variable that is being assigned. The instance variables width and height are actually given the default values 0 and 0 because they are not initialized in the constructor. When the toString is called, it will use the instance variable values given. We can actually avoid this confusion by using the keyword this to specify which variable we are intending to use in our program. This is a reference to the current object whose method and constructors are being called. Whenever this is called, it is referring to whatever object is calling the method or constructor. Because this is a reference to the current object, we can use the dot notation to access the instance variables of the object. By writing this.width and this.height, we are specifically accessing the instance variables associated with this object. With the simple change, the program outputs the expected result. This is because this.width and this.height are calling the instance variables. This.width and the formal parameter width are two distinct variables, and thus do not have a naming conflict in regards to scope. Because this is a reference to a specific object, it can also be used to call an object's methods. Suppose we wanted to create a method to compare the area of one rectangle to another. We could do so by writing a hasGreaterArea method that took the area of one rectangle and compared it to another. In this example, we see that the keyword this can be used to call the object methods, just as otherRect.getArea gets the area of the rectangle object otherRect. In practice, whichever object is calling the method or constructor is the one that is being referred to when this is called. In this example, when rect.hasCreatedAreaComp is called, this.getArea is using the attributes of rect when calculating the area. This can also be used as an actual parameter to pass the current object to a method. If we change the previous method getArea to have a rectangle object as a formal parameter, we can call getArea this in the hasGreaterArea method to pass the entire rectangle object to the getArea method. Now when getArea is called, getWidth and getHeight will be called on the object referred to as this. Let's try a practice problem using our superhero and power classes. We are going to create a method that compares the strength of one superhero to another. As a reminder, here are the superhero and power classes with a couple of getter methods. Notice that we use the keyword this in these class files to indicate the instance variables that are being initialized and returned. Before moving on, see if you can figure out the implementation of isStronger. Here's the pseudocode for our practice problem. Let's start with the method signature. We want to make this a public Boolean method that takes a superhero object as a formal parameter so we can compare the strength of one superhero to another. Now we need to get the strength of the current object. We can do this by calling this.power to access the power object in the current superhero, and then calling getStrength on that power. It's important to note that we can make multiple dot calls in our programs. In this case, this.power.getStrength is calling the method getStrength on the this.power object. The next step is to find the strength of the other superhero, and we can do that by creating another variable and storing the value hero.getPower.getStrength. This is using two different dot commands, so let's explore this a little more. The program reads the dot notations from left to right. The first method called on the object hero is getPower. This will return the power object to the program. The next method called is getStrength. GetStrength is being used on the power object that has been returned from getPower, and will return the strength value stored in that power object. Because the parameter hero belongs to the superhero class and is being called within the superhero class, we can actually access the private variables of hero without having to call getPower. In this case, we can just write hero.power to access the instance object power and then call getStrength directly on the power object. We cannot do the same thing with strength because strength is an instance variable of the power class, which is not a part of the superhero class. This will result in an error. Finally, we can return a Boolean comparing the strength of the existing superhero to the superhero listed in the formal parameter. We can shorten this program to one line by comparing the calls to strength directly, as opposed to storing the strength values in individual variables. Now that you've learned about the this keyword, let's get some practice using it in the CodeHS editor.